Okay, so I'm very pleased to introduce Philippe, who I knew when I was postdoc at the Max Planck Institute in Leipzig. So Philippe, he's a psychologist by training, clinical psychologist, and then he worked. So I think you did your PhD in Leipzig, right, in the Max Planck, and then you moved to Mannheim to work with Michel Bessa on the psychiatric disorder and bipolar disorder, etc. And then you went back to Leipzig to work with Tanya Singer on that resource project on the effect of different kinds of meditation training on the social functioning at different level, emotional and theory of mind, etc. So I guess, and now you are professor, full professor at Dresden, and you are still working on social aspect of both psychological mechanism and brain mechanism, I guess, right? And you now have your own group, and you will present your different studies and results, right? Thank you so much to be here.
Thanks a lot for inviting me. I'm really quite happy to be able to show some of the more recent work on the social brain, if you want to call it that. And I think I'll just get right started. Why would you want to think about something like the social brain? We as humans, we are highly dependent on each other, especially towards the beginning and the end of our lives. We really depend on other people. But also in between for emotional support and so on, other people are really important for us. Social relations are highly complex, and oftentimes they go relatively well. We are quite good at managing even complex social relations, but they also don't go so well all the time. And it's important to understand a bit more about the mechanisms that enable social relations. And as they are complex, they might even tell us about something about the architecture of the brain in general also, I think. And lastly, being lonely is a very dangerous thing. Being isolated, being and not part of a social group is something that is also really bad for our mental health. And this is a factor that cannot be underestimated, really. You might know the data by Julian Holt-Lunstad, where she looked at things that could predict mortality, where she found a lot of the things that you would expect, like physical activity, the BMI, smoking, of course. But at the top of the list, there were two social things, social relationships, high versus low social support. This is really strong support, getting strong support by other people, and also a complex measure of social integration that she looked at, which looks at how many friends do you have and how big is your social circle, are you in a close relationship, and so on. And we recently looked at this also in the current situation, which is kind of special in that regard. In Germany, we had a quite strict lockdown last year, at the beginning of last year, March and April. And we asked people in an online questionnaire about their stress but also their social lives and how they went. And we differentiated here between people who previously or currently had a diagnosis of a mental health disorder and compared those to people without a diagnosis. As you can see, the distress level was in general higher in the people who had a diagnosis than people without a diagnosis. But what we also found was that social factors are important for the distress level. For instance, when we look at social resources, for instance, on the left side, people who have had a mental health disorder. On the right side, people who have never had a mental health disorder. And as you can see, over the time, what you can see is here that the strict lockdown ended sometime towards the end of April, and then we went into a transition period with loosening, where the measures were loosened somewhat. And what you can see here is that people's distress levels decreased over the time period, but not for people with low social resources if they also had a mental health disorder diagnosed currently or previously. Similarly, for social isolation, we see that people who are relatively socially isolated, they and affected by a mental health disorder, they don't really show any decrease and have increased levels of distress in that time. And lastly, another factor, empathic disconnection. This is a bit of a weird term here. What it describes is the ability to not be too over-involved with the suffering of others. And what you can see is that people who have been affected with a mental disorder have increased levels in general, as you can see, but also if you're particularly low in empathic disconnection, you don't show a decrease. If you're high, you show a decrease, but you start at higher levels. So what we can take from this is that, especially in times where social connections aren't as easily lived as they usually are, social resources are especially important for people who are vulnerable, vulnerable in terms of their mental health. So what are important mechanisms that allow us to be social? What is something like the social brain? There are, of course, a whole range of different factors that play into this: biological emotion detection, affiliation, social attention, and so on, including also two more abstract factors, theory of mind and empathy. And those are the ones that I will be focusing on today. I think they are a bit special. What do I understand? How do I define these terms here? The theory of mind, I mean the ability to track others' intentions, desires, goals, but also emotions, but to do this on a more abstract level. So to kind of gain propositional knowledge about the state of another person, the mental state of another person. And empathy is the sharing of others' emotions. Some people would rather call this emotional empathy. It's so I don't use it here as an umbrella term encompassing all kinds of different things, but really very specifically for sharing others' emotions, yielding an isomorphic affective state in the observer, isomorphic to the affective state in the person that is being observed. Why do I focus on these two functions here? Both of them yield us a representation, some kind of representation or image, if you will, of another's internal states, unobservable internal other states. And they have been investigated quite a lot also in social neuroscience, of course. These are meta-analyses here. You can see that theory of mind has been associated with activity in this network that really largely overlaps with the default mode network. Empathy has mainly been associated with another network. As you can see, it involves anterior insular regions of the anterior cingulate cortex, more the salience network or frontoparietal control network, ventral attention network. Depends a little bit on how you look at it, and it spreads out a little bit also. Now, a problem with all of these meta-analysis is that these are pooled meta-analyses, and people have used all kinds of different paradigms and tasks to study these processes. And when you pool across them, you kind of smear over a lot of differences, and you cannot really understand differences as well. And especially in the field of social neuroscience, there's kind of terminological smearing also going on. And I alluded to this a little bit when I talked about empathy. Empathy, for instance, has been used as an umbrella term for all kinds of things. There people differentiate between cognitive empathy, emotional empathy, and also for theory of mind. Some people differentiate between cognitive and affective theory of mind. And with these pooled analyses, you cannot really get at differentiations between the different task groups that might give you insight in whether there are different functions going on. So what we did in a different type of meta-analysis, this is work by Matthias Schutz mainly, is that we looked at task groups separately. And I will start with the empathy tasks that we collected here. We grouped them into 5 different groups of tasks, and they range from observing pain, for instance. This is something like a classical empathy task where you see somebody else cut their fingers, or where the finger is slammed in the door. And then we did meta-analysis across all tasks that were in this particular task group. So for instance, for these observing pain studies, this would look like this, and it looks quite a lot like what I showed you already. So you have the anterior insula bilaterally, you have anterior cingulate cortex, but you also do have quite a bit more going on, as you can see here. There are many other tasks, just two more examples. For instance, evaluating situated emotions. These are tasks where you are presented with more complex stories of others, and you you kind of evaluate their emotions in a situation. You get a lot of situational factors in it, not just an image of a finger being pricked by a needle or something. Or also reasoning about emotions, more complex tasks where you are shown a series of pictures, and you're supposed to kind of deduce what the likely outcome of this is going to be, and the correct one here would be that this other person is kind of comforting this sad child here. So you even make a deduction about based on the effect of the other. And we did meta-analysis for each of these task groups. And what you end up with is a lot of different meta-analysis, as you can see here, a lot of different maps of the brain. And in a second step, we tried to find, in a data-driven way, find commonalities and differences between these different maps. As you can already see visually, there are some differences. For instance, when you look at regions here in the temporoparietal junction region, where you see activation here for reasoning about emotions, but not so much in the other task groups, for instance. But there are also some commonalities, like the anterior insula seems to be involved in all of these tasks here. Before I move to this clustering, I will also show you the theory of mind tasks that we included. Here we had 6 different task groups, ranging from false belief tasks. You might know the classic SLEN task where 2 dolls are interacting with one another, and you're supposed to predict the action of a person based on their false belief about the location of a ball in this case. Social animations, another example. These are the high decimal simulation figures, where 2 geometric shapes kind of interact with one another, a bigger one and smaller ones, for instance, and you're you cannot help yourself but ascribe a mental state to these geometric shapes based on their interaction. Or also very well known, the reading the mind in the eyes task, where you just present it with the eye region, and you're supposed to choose a word that best describes this expression here. For instance, joking or amused or relaxed in this case. And again, we get a lot of different meta-analyses. Each of these is basically one meta-analysis of this task group. And again, as for the previous one for empathy, you see that there are quite some commonalities. For instance, there's almost always some activation in this temporoparietal region, even if small for some of the tasks. But there are also differences. For instance, for the reading the mind in the eyes, we see that the anterior insula is also involved, but not for any of the other task groups. Dorsomedial, anterior medial prefrontal regions are also quite involved in some of the tasks, but also not in all. Now, as I said, what we did now in the next step is we clustered the task groups based on the maps that they yielded. So the different maps that we found here, how would they cluster based on their activation patterns? And what we ended up is this kind of dendrogram that you can see here. On the bottom, you see all of these different tasks. If they start with a T, then they come from the theory of mind group. If they start with an E, then they come from the empathy group, the emotion group. Here are all the specific tasks. But what you can see already is, just visually, is that some are closer together than others. For instance, the false belief task and the trait judgments task, where you judge other people based on their traits, or you ascribe traits to other people. They seem to be relatively closely related, and quite far from this group, for instance, is the observing pain group that is here towards the other end of this dendrogram. And now we can, what we can do is we can use statistical procedures basically to find the best solution. Where would you make a cut here? What are sensible groups? And what you end up is, with the best solution is a 3-cluster solution, where these 3 are grouped together in kind of we termed it here a cognitive cluster, because these are really the kind of classic theory of mind tasks that do not involve emotion at all. An affective cluster where you have many of the classical empathy tasks, for instance, the observing pain in others, or sharing emotions or pain, or observing emotions of other people. Now, interestingly, the reading the mind in the eyes, which is usually described as a theory of mind task, also ends up in this group. This is really not based on any conceptual discussion here, but it's really based on just on the activation pattern that the reading the mind in the eyes task yields. And given that it shows emotional eye expressions mainly, it might make sense that it's based on the activation patterns. It's rather clusters together with classical empathy tasks. Now, interestingly, we also found a 3rd cluster, and this 3rd cluster includes these more complex empathy tasks, for instance, the situated emotions task, or the reasoning about emotions task, but also 2 tasks from the theory of mind group, the situated emotions, social animations. These are the triangles, for instance, the interacting geometric shapes, and also the rational actions task group. These are tasks where you reason about actions of others, but not based on their emotions, as you would do for the reasoning about emotions task. The social animations, the interacting triangles, the scenarios that they show are often also a bit emotional. So one is kind of chasing the other or tricking the other or things like that. So these are all more complex tasks that if you just look at the task themselves, might involve some emotion, but are also clearly involving some reasoning component or more complex understanding of a situation of somebody else. And these seem to go together. Now, there's another solution that is relatively well also. This would be an 8-cluster solution. It's basically, except for a few examples, the task groups themselves. So the groups that where we put the different individual paradigms in. And this just shows, in my view, that there's a lot of variance also between the tasks that is specific, and that is not a social process per se, but is specific to a certain task, and is not necessarily on a more abstract level as a social function. Now, what we did in the next step is that we kind of mapped, kind of used these classes and looked at what the brain maps for these different classes would look like. It's basically a meta-analysis of task groups in the different clusters, and what you get is a kind of a dendrogram of brain maps. Is basically this dendrogram, but in terms of brain maps. And as you can see for the 3-cluster solution here, the brain maps are quite different. You get this mainly default mode network-like looking activation pattern for the cognitive cluster with these anterior, posterior midline regions and all the temporal parietal regions. You get the anterior insular and anterior cingulate cortex and these IFG and lateral regions for the affective cluster. And for the intermediate cluster, it seems like you get a little bit regions from both of these networks. You do have, to a lesser extent, anterior insular in here, but you also have these temporoparietal activations, and you also have midline activations that are partly resembling this map, partly also this map here. So it really, from this map, one could already guess a little bit that maybe these tasks are kind of a combination of the 2 networks that you observe for the affective and the cognitive cluster. Just for the sake of to complete it here, these are the maps for the 8-cluster solution. They are basically relatively similar, but of course also some differences. That's why they are grouped together. But I don't want to spend too much time on those here. Now, what we can also do is look at these patterns here more specifically. And what we did is a neuroscience decoding of these three clusters, basically. And what you can see in red for the affective cluster, basically, you have strong loadings on terms like pain, fear, affective phase, or also ASD, which is also in there. For the cognitive cluster, you get the terms theory of mind, mentalizing, mental states, beliefs, and so on. And for the intermediate cluster, it seems like it's not as clear again. You get a bit terms from, or it overlaps a bit with the shapes that you get for the two other networks. So this would, in a way, also argue for the intermediate cluster really being an intermediate cluster and kind of involving aspects of the other two clusters. We also did one different way to approach it is to look at overlaps with macro scale cortical organization. What we did here is we made use of a study by Daniel Margulies. What he did is look at a lot of resting state data and find a principal gradient, basically, that or one gradient that can describe macroscale cortical organization, which ranges from sensory unimodal regions to more abstract transmodal regions. Basically, if you look at the networks here in the brain, you see that the abstract transmodal regions are mainly the default mode network again. And the sensory unimodal regions are regions in the visual cortex, for instance, or primary motor and somatosensory cortex, for instance. And then there you have these more intermediate regions here. And what we did is basically we looked at the classes and whether they would overlap with different parts of this gradient. And this is what we get for the cognitive cluster. You can see that the biggest overlap was with the far abstract transmodal end of the gradient. For the affective cluster, the biggest overlap was with these intermediate regions, which do include, for instance, the anterior insula. And for the intermediate cluster, you see kind of a bimodal shape here with overlaps of this intermediate regions, but also of the cognitive transmodal abstract end. So this would kind of also argue for this network being kind of a combination of the other two. Now, as far as what we looked at so far, it's what you cannot be sure is that because it's a meta-analysis, you cannot be sure that co-activation of the two networks, for instance, for the intermediary task cluster, really come from the same task, from the same study, basically. It could also be that they come from different studies, but studies that group together. That's why you get overall activation in the two networks. And that's why we now approach this question also with meta-analytic co-activation mapping. And we kind of used, it's based basically on these clusters that we found here. And we and on the meta-analysis, on the studies that are included in this meta-analysis. And we looked at specific regions of interest here, the anterior insula, the temporoparietal junction is kind of key nodes of this network, and also midline regions. And just exemplarily, I wanted to show you that what you can do is when you look at the meta-analytic co-activations from the insula, for the affective cluster, you get again the typical network that you would expect here. It overlaps with the affective cluster here. For the cognitive cluster, you get a different network that resembles most the cognitive cluster. And for the intermediate cluster, again, you get kind of co-activation with the insula with both of these networks. And the same is true for the temporoparietal junction when you look at the co-activations here. So also on a single study level, one could say that there are tasks that really activate parts of both networks, including, for instance, the anterior insula, but also temporoparietal regions and these for instance, posterior midline regions, preconius, for instance. So this, what we can take from this, or I think what we can take from this is that there seem to be tasks that are complex enough, or you could view it in two different ways. You could either say that there are tasks that are complex enough to really require both functions at the same time, or that are experimentally not clean enough and don't really separate the functions well enough. Both could be of interest, of course, and to be able to study both functions in parallel, we develop a specific task which we call EMPATOM, and I'm going to go into some detail regarding the task where we can study empathy and theory of mind in parallel for the next part of the talk. So here we present people with a short video. It's a narration that one person gives, and it can be either neutral or in an emotional narration. Afterwards, we ask people how they feel now, with the logic that if you feel more negatively after an emotionally negative video, for instance, you empathically shared that person's emotion. What we see is that people do indeed report to feel more negatively after emotionally negative videos. And this goes along with activation in a widespread network, which overlaps with meta-analyses of empathy, including the anterior insula on both sides, and in which activation also is parametrically modulated by the valence ratings that people give here. So the more you are touched by a certain video, the more you will activate these regions in this network. I'm going to jump over this and move to the second part of the task. We also ask people questions about the video that were either about the thoughts of the person, Anna in this case thinks that ABC, or factual reasoning, which were also about the contents of the video, but rather ask whether some worldly affairs are true or not true. And what we see here is activation in a different network. And as you can see, again, it overlaps quite well with the default mode network. You have all these temporal parietal regions and the anterior posterior midline regions. Interestingly, you don't only get this for the question period when you ask a theory of mind versus these control questions, but also already in the video phase, when you look at videos that do have some theory of mind demands, videos that we coded them basically in a way that we couldn't look at videos that where the narration is in a way that you are a bit puzzled and you need to deduce the thoughts of the person yourself. And to a low degree, activation in this network, pooled activation in this network also correlates with behavioral performance. So at least the direction is that more activation in this network yields better performance in responding to these questions. Now, because we have tested both of these functions within the same people, within the same task, we can also directly contrast them. And this is what we did here. We kind of contrasted the theory of mind and the empathy effect. And as you can see, this really brings out the two networks very clearly with the anterior insula, for instance, again, and these all these temporal regions, for instance, for theory of mind. Now, to look at the embedding of the task-specific networks that we found here in larger functional organization of the brain, we also looked at how these peaks would fall in resting state networks and seeded basically in resting state from the same participants from these functional defined seeds. And wherever you start, you can see that you get the same patterns, at least with the, for instance, these anterior midline regions for theory of mind and anterior insula for the empathy regions. So it kind of shows up again in resting state. We can also, because we have both functions in the same people, we can also look at how they are directly related, how inter-individual differences basically are related here. And this is what we looked at with correlations. For instance, we looked at the valence ratings, the ratings that participants gave after the videos and the performance. And what we found here in these almost 180 people is that these were clearly not correlated. Also, when we form a composite score on empathy behavior, including also other tasks, and the same for theory of mind, there's no correlation here. And now moving to the neural level, when we look at the activation strength in these networks, we don't see a correlation there either, and also not when we look at the video phase only. I told you that during the videos we can look at videos that have high theory of mind demands also, and so we have the networks within the same time period, and even then there's no significant correlation between these two functions. So it seems like they can at least be really dissociated, which we also saw in the meta-analysis, that there are tasks that can engage them separately. Now, we can also look at this on a structural level. This is work by Sophie Falk. What she did is she looked at structural covariance in cortical thickness, basically starting with the seed region and looking which other regions of the brain are covarying with the thickness of the seed region, and then looking at is this modulated at all by a certain function, in our case, empathy and theory of mind. And what she found is that seeding from the anterior insula, if you look at the unmodulated covariance, you get basically many regions of the brain. If you look at the modulated one, you get significant other regions, for instance, here in these parts of the brain for empathy, but none for mentalizing, and the other way around. When you look at the temporoparietal junction in an unmodulated way, again, you get large parts of the cortex. But if you look at the modulated parts that are modulated by theory of mind performance, you get, for instance, these anterior midline regions, but no significant structural covariation when you use the empathy scores here. So also on the structural brain level, they are quite clearly dissociable. Now, we looked at a couple of groups also where we thought that maybe in these groups we can differentiate these. For instance, in a group of aggressive offenders, these are people who committed serious bodily harm, like violent crimes. And here there was no significant difference in the theory of mind performance, but these people rated their emotion to be less negative after the emotional videos. So at least on the subjective level, they report that they don't share the other's emotion as much. We are now following this up on with an imaging study also, which is kind of difficult in this population, as you can imagine. When you look at aging, for instance, changes over the lifespan, here we see a clear change in theory of mind. Older adults are showing behavioral impairments in theory of mind, but also in the control condition, interestingly, even more so actually in the control condition than young adults, but no differences whatsoever in terms of how much they share the other's emotion. So kind of the reverse pattern that we saw in these aggressive offenders. You can also try to modulate one or the other network, and we tried this here with music. And what you see is when you add emotional or neutral music, is that you get an interaction on the x-axis here. You have the music, can be either neutral or negative, and on here you have the empathy ratings. And then we have the neutral and emotional videos. And as you can see, for the neutral videos, it doesn't make a difference. The empathy ratings don't differ between neutral and negative music, but it does make a small but significant difference for the emotional videos. Here, people report to have even more empathy when the added music was emotionally also. And there was no modulation whatsoever in terms of theory of mind here. Can we also induce long-term plasticity in these networks? This is a study that was done at the Max Planck Institute. Pauline alluded to it. It's part of the resource project led by Tanya Singer, where we involved people in different modules where they trained different functions. Each module was 3 months of length. And one of the modules focused really on metacognition, perspective taking on self and others with meditation and dyadic exercises. Another module focused on affective functions, generating positive affect for the other, and dyadic exercise where you also empathically listened to the other telling an emotional narration. And what we see in the empathy and theory of mind tasks that I just showed you is that theory of mind performance is a little bit enhanced after this, this cognitive module here. While a retest control group that that did no training, a passive group basically, showed no effect, and also the group that did this affect training also showed no effect. In contrast, compassion ratings, this is kind of related to empathy, positive emotions, another social emotion basically that we looked at here. We see an increase after this effective module compared to the passive group, and also compared to the active group here. And this goes along with changes in cortical thickness also. For instance, people with the strongest increase in the anterior insula also increased most strongly in the compassion ratings after the affect module. This temporoparietal region, people who showed an increase in cortical thickness here changed most in the theory of mind performance after the perspective module. So also in long-term changes, we can kind of induce changes differentially here. Does this have anything to do with social behavior also, how we behave towards other people? This is kind of what you want to ultimately get at, right? You don't only want to know what people think or feel about others, but how does this affect their social behavior? In one recent study, what we did is we kind of used the task again that I just showed you also, and added a prosocial rating in the end. Basically, the question, would you be willing to help this person? And what we see is that after the emotional compared to the neutral trials, people report to be willing to help more often than after the neutral trials. And this also varies with what people rate. So the more negative the individual emotional rating was, the higher the willingness to help. And there was no such correlation in the neutral trials. These are the emotional trials here, and these in the neutral trials. And interestingly, it also seems important to understand other people, to understand what they are thinking on a cognitive level. What we see is a very small effect, but also significant here, that if you responded to the theory of mind question correctly, if you correctly deduced what the person was thinking, you were a bit more willing to help. And this was not the case for the factual reasoning questions. If you responded to the factual reasoning question also about the contents of the video correctly or incorrectly, that doesn't affect at all whether you were willing to help the other person. And in a previous study, Anita Tusche looked at this more deliberately, also on a neural level. She had people do a donation task, presented charitable organizations, then asked people if they were willing to spend some of the money that we gave them, basically, on this charitable organization. So you could donate a certain amount of money that you were willing to donate. And then in the end, one of these trials was actually also implemented. And what you can see is that across the a bit more than 30 participants here, that people vary quite dramatically in how much they were willing to donate. People on the far right end here donated on average much more than on the left end. But you could also see that within each person, you can find trials where they were willing to donate more than in other trials. And now we also asked people after this task here how much they felt empathy for the beneficiaries of this charitable organization and how much they were able to take the perspective of the beneficiaries of this organization. And these behavioral ratings were already successful in predicting, in a regression, predicting whether a certain organization, a certain trial would fall into this category of high versus low donations. Now, on a neural level, what Anita did is that she looked at whether there are regions in the brain where she can decode with a multivariate pattern approach, where she could decode whether people reported high or low empathy for the beneficiaries of that organization. And a region in the anterior insula showed a significant prediction here. Region in the temporoparietal junction was significant in terms of how much people reported to take the other's perspective. And this was not significant the other way around. So the empathy ratings were not predicted by a temporoparietal junction activation patterns, and perspective taking wasn't predicted by anterior insular activation patterns. Now, Anita, in the next step, she used these decoding algorithms, basically these activation patterns here, to see whether they would also be predictive of whether people donated or not. And this was also significant. As you can see here, about 60 to 65% with that accuracy, she could predict based on these patterns here whether people would donate or not, which was significant compared to random simulations here. And she also did this task, the empathy and theory of mind task that I showed earlier, in the same participants. And what she found was that the weights with which these patterns basically went in, the weights in predicting prosocial behavior that these different activation patterns had was determined by how much people on a kind of trait level share other people's emotions or are correct in mentalizing. So even in an individual task, you can find tendency of people to share these emotions, which will determine whether they rely on empathy to make a decision whether they would help another individual or not. Now, lastly, I've talked a lot about how these networks can be dissociated within this task, but even within this task, we can look at how they are related. And what we did here is that we chose two key nodes of the respective networks, the temporoparietal junction and the anterior insula, and looked with dynamic causal modeling at whether they were coupled or not. And what we found was that the best model, the winning model, is one where you see an inhibitory connection from the anterior insula to temporoparietal junction that was modulated by emotion. So in these highly emotional videos, basically, there's a negative, an inhibitory connection from anterior insula to TPJ, and this has effects also on theory of mind performance. The performance in these questions was a little bit impaired in people who have a strong negative, this strong negative coupling here, this strong inhibitory relation. So even in a task where the decisions that you make don't really depend on the emotion of that video, there seems to be some interrelation between these two networks. And if you have other tasks where these relations are made more explicit, then you see a lot more of connectivity going on there. There are not that many studies, but in a recent review paper, we looked at the ones that we could find. This is the study that I just showed you with the inhibitory connection from insula to TPJ. And the few other studies that we found different patterns here. For instance, also inhibitory patterns, but also excitatory patterns where one network would excite the other, and connections seem to go in different directions. So from more default mode regions to control network regions, and the other way around. Now, in my view, these are all more complex social tasks that might also fall in the category that I showed you in the meta-analysis earlier, in the category of tasks that involve both functions. What is needed now, I think, is a more systematic framework to study these interconnections, because at the moment we don't really know what exactly they mean and why they come in these different shapes in the different tasks. So to summarize, I think theory of mind and empathy can be clearly dissociated meta-analytically within task and subject. There's a non-correlation between these two functions. Also in development and psychopathology, we can dissociate them, and also in terms of plasticity. But I think, and this is a really crucial step, I think, for social neuroscience now, is to also look at these co-activations and interactions of these two networks for more complex social functions, like the ones that I kind of motivated the talk with earlier. Now I will end here. I would like to thank all the people in the lab in Dresden. I would like to thank also Matthias Schutz, especially, who I'm collaborating with a lot on the meta-analysis part. other people who worked on the Empatome task also, and on data from this empathy and theory of mind task, Mathis Trautwein, Anne Böckler, Sophie Falk, and also Tanya Singer and all the other people who contributed to the work. And with that, I would like to thank you for your attention.